Today you will create a scatter plot and use it to find regression equations or trend lines which are used for making predictions. Now, a scatter plot is a graph that relates two sets of data as an ordered pair, an independent variable and a dependent variable. Correlation goes with the strength of the relationship of the data. The stronger the relationship, the stronger those points are next to one another, the more accurate your data is for making future predictions. There are 5 different types of correlation. There are negative correlations, where your slope is negative, indicating a downward trend in whatever you're talking about. There are positive correlations with positive slopes, indicating an increase in whatever you're talking about. Notice that there's strong and weak correlations. So remember, the stronger the relationship, the better the data is at making future predictions. And then there are scatter plots that have no correlation at all. Notice that the dots don't seem to form any type of recognizable pattern. So you can't really make a line of best fit. You can't really use the data to make predictions about the future. A line of best fit is a trend line that lets you make predictions concerning the data. And that is what we are going to do today with this example below. Let's look at it. The table shows the median home prices in Florida. Create a visual representation of the data. This means some type of graph. Since we are particularly talking about scatter plots, today we will be making a scatter plot. This is not the only type of visual representation we could do. We could do a bar graph. We could do a pie chart. There's many different things we could do. But today we're doing a scatter plot. Then, what is the equation of a trend line that models a relationship between time and home prices? So obviously they want us to find an equation of a trend line or a line of best fit. We will then use the equation to predict the median home price in 2020. So here's our table. The first thing we need to do is decide what is our independent variable, our x variable, and then what is our dependent variable, the y's. Remember that an independent variable has nothing that affects it. It's always the same no matter what. This has to do with time. No matter what, time passes exactly the same always. So time always marches on. So we're going to say that our independent variable is going to be the year, but specifically years since 1940. The reason I'm going to say years since 1940 is because it will be much easier to graph than 1940, 1950, 1960. It'll be easier to graph it and plug it into equations. Our y variable then will be the home prices, because notice that the price depends on the year. So let's look at our chart. Here's where we're going to create our scatter plot. Remember that independent variables, the x's go this way, and the dependent variables go this way. So I'm going to list years since 1940. That's what's going to be my x-axis. And then prices will be my y-axis. We're going to start, this is going to be 0, because think about it, when you start at 1940, how many years have passed? None. No years have passed when you start at 1940. Notice that it goes from 1940 to 1950. Well, how many years have passed from 1940 to 1950? The answer is 10. 10 years have passed. We'll continue doing this. So the next one is 1960. That's 20 years have passed. Then 1970. That's 30 years. 1980, 40 years, 1990, 50 years, and then 2000, so 60 years. So notice, years since 1940. This represents 1950, 1960, 1970, so on and so forth. Now let's look at our data for the prices. Notice we go from 23,000 to 105,000. I like to keep everything in either 5 or 10 intervals. So I think I'm going to start with 20,000 and then go up by 20 each time, 20,000 each time. So if I start here, this is going to be 20,000. If I go up by 20,000 each time, this is going to be 40,000, 60,000, 80,000, 100,000, and then at the very top, 120,000. Make sure that all your data will fit on your scatter plot. 23,100, yep, that'll fit. The last one is 105,500. Yes, that will fit. So our y-axis will fit all of our data. Now we have to plot our points. The first point is 1940 and 23,100. Remember, this is our x, this is our y. Well, in 1940, remember, no years have passed, so we're here, and then we're at 23,100. So right about there. That's going to be our first point. Our next point is 1950, so 10 years later, and then 40,100, so just above the 40,000. The next point is 1960, so 20 years later, and then 58,100. 58,100, so right about there. The next point is 1970, and then we go to 5,700, 57,600. So right about there. Went down a little bit that year. In 1980, we're at 89,300. So 89,300. In 1990, we're at 98,500. 98,500, right about there. And then in 2000, we're at 105,500. So right there. Here is our scatter plot. Notice we just took all the data in the table and represented it in a visual XY axis. I am now going to take a straight edge and create a trend line. So I'm just going to line up my straight edge and try to go through as many points as I possibly can. That looks pretty good. You do not have to go through all the points, because remember, it's a line of best fit, not perfect fit, best fit. So here's the trend line that I've created. We have now created a visual representation of the data. The next thing said, what is the equation of a trend line that models a relationship between time and home prices? So now we have to find an equation. Notice that this function is a linear function. And we're going to put it in the form y equals mx plus b, where m is your slope, recall that it's your slope, and b is your y-intercept. Well, let's first look at our y-intercept. So go over to your graph. Again, we're looking at where the trend line intercepts. Notice it seems to intercept right there. Well, there is halfway between 20,000 and 40,000, so our y-intercept is going to be 30,000. To find slope, you have to recall back to Algebra 1, where we do y2 minus y1 over x2 minus x1. So we need 2 points that are on this trend line. Let's pick something easy. As I look at this, I notice that right here, we seem to hit perfectly on the grid. That point is 15, 45,000. 15, oh no, not 45,000, I apologize. 50,000, because it's halfway between 40 and 60. So 15, 50,000. Then it seems to be that we hit pretty accurately on this point right here. Ooh, there's an even better one right here. Look how perfectly it hits the grid right there. Let's use that point right there. That point is halfway between 50 and 60, so 55, comma, and then we're right here at 100,000. Now we have 2 points, 2 x's and 2 y's. We're going to plug that into our slope formula. So y2 is 100,000 minus y1, which was 50,000, over x2, so 55, minus x1, which was 15. Plug all of that into your calculator, and you'll find that your slope is roughly 1250. 1250. So that's going to be our slope. So we're going to have y equals 1,250x plus 30,000. So now we have found the equation of this trend line. The last part says use the equation, so we're going to use this equation to predict the median price of a home in 2020. So our x value is going to be the year 2020. But remember, we haven't been doing 1940, 1950, 1960. We've been doing years since 1940. Well, 2020 is 80 years since. So we're going to be plugging 80 into our equation. So y equals 1250 times 80 plus 30,000. We plug that into our calculator. And we find that the home price is going to be $130,000. So roughly, in the year 2020, your home is going to be $130,000. And this is how scatter plots and trend lines work in order to make predictions. We'll practice this in class tomorrow.